Imagine a group of friends keeping track of expenses during a trip. Every time someone pays for food, fuel, or tickets, it's written down in a shared notebook. Once an entry is made, no one is allowed to erase or secretly change it, and everyone has a copy of the same notebook. That way, there is no confusion, no arguments, and complete trust. Hi, I am Satish Chaudhary and welcome back to In Simple Terms with Satish. Today, let's explore blockchain, the technology that is redefining how we store trust and truth in the digital world. Blockchain is a system of recording information in a way that makes it nearly impossible to cheat or tamper with. At its simplest, it is a digital ledger, a record book that's duplicate across many computers. Every new entry is added as a block linked to the previous one, forming a chain. Since everyone has the same copy, no single person can secretly alter the past. In simple terms, blockchain is a trust machine. Think of blockchain like the old accounting ledger kept by a shopkeeper in a small town. Every transaction, like who bought rice, who paid, or who still owns money, is carefully written down. Once ink hits the page, it can't be erased without leaving a mark. Now imagine instead of the shopkeeper only, the entire customers also have a copy of the same book. If someone tried to cheat by changing their page, the rest of the community would immediately see the mismatch. That's how blockchain works. A permanent, shared record that everyone can trust. Let's break down the name itself, blockchain. A block is like a page in that ledger. Each block contains a group of records, for example, a list of transactions. Once a block is filled, it's locked, stamped with a unique digital print and linked to the block before it. All these blocks together form the chain, a continuous timeline of records where nothing can be rearranged or erased. If you go back and try to change one block, its fingerprint changes and the whole chain falls apart, which immediately exposes the fraud. Now who makes sure the chain stays safe? That's where nodes come in. A node is just a computer connected to the blockchain network. Every node has a full copy of the chain, and whenever a new block is added, all the nodes check and agree that it's valid. This teamwork is what keeps blockchain secure without needing a single boss or central authority. Imagine a classroom where children are collecting stars for good behavior. Instead of only the teacher writing it on the board, every child writes their stars in their own notebook. If one child tries to sneak in an extra star, the others quickly notice that their notebook doesn't match. To keep it fair, they all agree on the correct score before moving forward. That's how blockchain works. It's like everyone keeping the same score together, making cheating nearly impossible and fairness automatic. Most people immediately connect blockchain with Bitcoin, and yes, it is a technology that makes digital money possible. It allows people to send and receive currency securely without depending on a bank in the middle. But that's only one piece of the picture. Think about food in supermarket. When you pick up a box of mango or spinach, how do you know where it really came from? Companies are now using blockchain to track food from the farm through transport all the way to the store shelf. If there is a safety issue, they can trace it back in seconds instead of days. In healthcare, imagine never having to repeat the same test at different hospitals or carry your medical files around. With blockchain, your medical history can be stored in one secure record where only you and the doctors you allow can access it. It also changes how agreements work. With what's called a smart contract, payments can be automatic. For example, if a freelancer finishes a project, the contract itself can release the payment right away. No waiting, no chasing invoices. And then there is ownership. Digital files like artwork, music, or even items inside a video game can be copied endlessly. Blockchain makes it possible to prove which one is original and who really owns it. That's where things like NFTs or non-fungible tokens come in. They give creators a way to sell and protect digital work the same way a signature proves a painting is authentic. Now, blockchain is not perfect. Some early systems used huge amount of electricity to keep themselves secure, but newer versions are finding greener, smarter ways to run. And while many people think blockchain is completely anonymous, the reality is little different. Your personal name may be hidden, but the actual transactions are visible to everyone. That's what makes the system transparent by design. So in simple terms, a block is a page of records, the chain is the timeline that logs them together, and nodes are the computers that keep everyone honest. Put them all together and you get a blockchain, a shared, permanent and trustworthy record system that's more than just Bitcoin. Think of a whiteboard at home where the family writes down the task, like who is doing the dishes, who is taking out the trash, and who is feeding the dog. Now imagine if every family member also kept their own mini whiteboard copy and everyone updated them together. If someone tried to secretly erase their task, the others would instantly notice the mismatch. That's how a decentralized ledger works. One shared record kept honest by the group. A decentralized ledger is simply a record of transactions like a notebook, but instead of being stored in one place, it is copied across thousands of computers called nodes. Whenever a new transaction happens, it is shared with all the nodes in the network. They check it, verify it, and agree it's valid, a process called consensus. Once they agree, the record is added to every notebook at the same time. Because everyone has the same copy, no single person or bank can secretly change history. Imagine a match where instead of only one scoreboard, every spectator also kept the track of score themselves. If the scoreboard suddenly shows something different, the crowd quickly spots the error because their own notes don't match. That's how a decentralized ledger works. Many identical copies keeps the record honest. In practice, a decentralized ledger is maintained through peer-to-peer network. When you send a transaction, it doesn't go to a single server, it goes to all the nodes. Each node verifies the details with math rules and digital signatures. Once enough nodes agree, the transaction becomes permanent and every copy of the ledger updates at once. That is why it is so hard to cheat the system. To change history, you would have to hack thousands of ledgers simultaneously, which is practically impossible. Imagine a group of kids trading Pokémon cards. To keep it fair, they all write down each trade in their own notebook at the same time. If one kid later tries to deny a trade, the others can point to their notes and prove what really happened. That's exactly how a decentralized ledger works. Honesty comes from everyone keeping the same record. You may not realize it, but the idea of a decentralized ledger can touch many parts of life. Imagine casting a vote in an election, knowing your wallet is securely recorded and can't be erased or altered. Or think about buying a concert ticket that's stored on a blockchain, where scalpers can't create fake copies and you can be sure it's authentic. Even universities are beginning to issue digital diplomas on decentralized ledgers, making them impossible to forge. Whether it's democracy, entertainment, or education, the idea is the same. Trust doesn't come from a single authority, but from everyone keeping the same record. So in simple terms, a decentralized ledger is like a scoreboard that lives on thousands of computers at once. Everyone updates it together, everyone checks each other, and no one can secretly rewrite history. Think about how you unlock your phone with a PIN or fingerprint. Your phone doesn't actually save the real PIN or the real fingerprint. Instead, it saves a scrambled version of it. When you try to unlock, it scrambles your input the same way and checks if it matches. If yes, you get in. That scrambled version, that's hashing. Today, let's talk about hashing, a method that gives every piece of information its own digital fingerprint. Hashing takes any information, say a word, a sentence, or even a big file, and turns it into a short code made up of letters and numbers. If even one tiny detail changes, like adding a single dot, the code changes completely. That's why hashing is so powerful. It proves whether something has been changed or not. Imagine a sealed envelope with your exam paper inside. Once the teacher stamps and seals it, any attempt to open or change the paper will break the seal. Hashing works the same way. It puts a unique stamp on data. If anything changes, the stamp no longer matches. In blockchain, hashing is what locks blocks together. Each block has its own fingerprint plus the fingerprint of the block before it. If someone tries to change even one block, the fingerprint no longer matches and the whole chain breaks. That's how blockchain shows if something has been tampered with. We already use hashing in our daily life. When we type our password into our email or social media, most sites don't actually store your real password. It only stores the scrambled version. When you download an app or a file, the website may show a little verification code. That's a hash used to check if your file was damaged or changed. Even digital signatures on documents are built on hashing to prove the content has not been altered. So in simple terms, hashing is like a fingerprint for data. It's unique, it can't be copied, and it proves whether something is the same or has been changed. It is one of the big reasons why blockchain can be trusted. Imagine a group of friends trying to order pizza. Everyone shouts out their favorite topping, but they can't place the order until most of them agree on the same one. If a person insists on pineapple, but the rest agree on cheese, the order will be cheese. That's how consensus works in blockchain. The group decides together and the majority rules. Hi, I am Satish Chaudhary and welcome back to In Simple Terms with Satish. In our last episode, we talked about hashing, the digital fingerprint that proves data has not been changed. Today, we'll look at consensus, the system that makes thousands of computers agree on what's true, even when no one is in charge. Now you might wonder, how do these computers actually agree? They don't just shout out answers like friends ordering pizza. They use rules based on maths. Every transaction is checked using a digital signature which proves who sent it and the history of the previous blocks. Once enough computers confirm that everything matches, the system locks it in. This process is called a consensus mechanism. Different blockchains use different methods like proof of work, where computers solve puzzles, or proof of stake, where those who own tokens help validate. But the goal is always the same, to make sure everyone's copy of the blockchain matches before it's updated. For kids, imagine a group playing a board game. One child tries to move 5 steps when the dice shows only 3. The rest of the players stop them and say, "That's not right." The group's agreement on the rule keeps the game fair. Blockchain consensus works the same way. Everyone checks and only what the group accepts go forward. In real life, consensus powers cryptocurrencies like Bitcoin, where it prevents double spending. It is used in supply chain where dishonest entries are rejected by the majority. And even in digital voting system, consensus ensures that only valid votes are counted and everyone sees the same result. So in simple terms, consensus is the group agreement that keeps blockchain honest. It is the vote, the safeguard, the reason thousands of computers can trust each other without a boss in charge. Imagine a treasure hunt where kids are racing to solve a riddle. Whoever cracks it first gets a prize and writes the name on the scoreboard. That's exactly how mining works in Bitcoin. Computers compete to solve puzzles and the winner earns a reward while securing the system. Today, let's explore mining, the puzzle solving process that makes sure new blocks are added securely. So who are the miners? In blockchain, miners are powerful computers run by people or companies. Their job is to gather new transactions from the network, bundle them into a block, and race against others to solve a puzzle that locks the block into chain. Here is how the puzzle works. Every block of transactions needs a special code called a hash. But the hash has to follow strict rules. For example, it must start with a certain number of zeros. To find this, miners keep changing a random number called a nonce and run the block's data through a hashing function. They try billions of combinations per second until one finally works. It is called proof of work because the work is all those guesses. It is incredibly hard to solve but very easy for everyone else to check once a valid hash is found. The first miner to find the right hash broadcast it to the network, and all other computers quickly verify it. If it is correct, the blocks get added to the chain. Why do miners do this? Because there is a reward. The winning miner gets a new coin created by the system, for example a new wheat coin, a transaction fees paid by the users for the transfers inside the block. This reward system motivates miners to keep the network running and secure. For kids, think of it like a classroom with math race. The teacher gives out a really tough problem. The first student who solves it correctly gets a gold star and writes the answer on the board. Once it is there, everyone accepts it as the official answer. Mining is like that, a tough race, a reward for the winner, and a permanent record for the group. In real life, mining is what makes Bitcoin possible. It stops double spending, ensures fairness, and keeps the ledger safe. But it comes at a cost. Mining uses enormous amount of electricity. The constant puzzle solving can consume as much energy as an entire country. That's why newer blockchains are turning to proof of stake, where instead of solving puzzles, validators use the coin they hold to prove their honesty. It uses far less power while still keeping the network secure. So in simple terms, miners are the computers that bundle transactions, solve difficult puzzles, and add new blocks to the chain. They do the work, they get rewarded, and the competition is what makes blockchain both secure and trustworthy. Imagine buying a snack from a vending machine. You put in money, press a button, and the machine instantly gives you your chips or soda. No shopkeeper, no waiting, no arguments. That's exactly what a smart contract does in blockchain. It runs the agreement automatically when the conditions are met. Today, let's explore smart contracts, self-running agreements that remove the middleman. So what is smart contract? At its core, it's a piece of computer code stored on blockchain. Instead of lawyer or bankers making sure both sides keep their word, the code itself enforces the rule. It follows simple if-then logic. If this happens, then that happens automatically. For example, imagine hiring a freelancer online. A smart contract would hold the payment and release it the moment the freelancer uploads a finished work. No delays, no chasing invoices, no arguing over trust. The blockchain ensures the rules are followed exactly. Think of it like a train ticket. If you have a valid ticket, the gate opens automatically. If not, it stays locked. There is no guard deciding. The system just works based on clear conditions. In real life, smart contracts are already being used. In real estate, they can handle property transfers without endless paperwork. In insurance, payouts can trigger automatically when conditions are met, like if a flight gets cancelled. In supply chain, smart contract releases payment the moment goods reach a verified checkpoint. And in creative industries, artists can get royalties every time their song or artwork is sold because the smart contract sends them their share instantly. Technically, smart contracts live on platforms like Ethereum, where developers write them in special programming language such as Solidity. Once deployed, they can't be changed, which makes them powerful, but also risky if the code has a bug. That's why audits and testing are so important before launching a smart contract into the wild. So in simple terms, smart contracts are digital agreements on the blockchain. They are like vending machines for trust. If the rules are met, the outcome happens automatically. No middlemen, no delays, no excuses. Imagine two types of libraries. One is a public library. Anyone can walk in, read books, and borrow them by following the rules. The other is a private library inside a school. Only students and teachers can enter, and the school decides who gets access. That's the difference between a public and private blockchain. Today, let's explore public versus private blockchain and why the difference matters. A public blockchain is open to everyone. Anyone can join the network, become a node, verify transactions, or even build application. Bitcoin and Ethereum are good examples of this. They are transparent, decentralized, and secure because thousands of computers around the world are involved. The trade-off is speed. Public blockchains can be slower and use more resources. A private blockchain is restricted. Only selected participants can join, and a company or group controls who gets access. These are often used by businesses to share data securely. For example, A group of banks might use a private blockchain to settle payments between themselves. It is faster and more controlled but less decentralized. Imagine a playground. A public playground is open to everyone in the neighborhood. Anyone can join the fun. A private playground inside a school is only for its students. Both have swings and slides, but the rules about who can play are very different. In real life, both types have their uses. Public blockchains are great for cryptocurrencies, NFTs, and open applications where trust comes from decentralization. Private blockchains are used in industries like healthcare, where hospitals may need to share patient data but only with authorized staff, or in logistics, where companies want to track goods but keep the system close to outsiders. Technically, public blockchain relies on open consensus methods like proof of work or proof of stake, where anyone can participate. Private blockchains often use faster methods like permissioned voting, since the participants are known and trusted. So in simple terms, public blockchains are open network where anyone can join, while private blockchains are controlled network with limited access. Both are blockchains, but they are designed for different purposes. When most people hear the word blockchain, they instantly think of Bitcoin. But blockchain is much more than digital money. It is like discovering that electricity is not just for light bulbs. It also powers your fridge, your phone charger, and even electric cars. Blockchain is the same. One technology, many uses. Today, let's look at many ways blockchain is being used in real world far beyond Bitcoin. Take supply chain for example. Imagine scanning a QR code on a packet of mangoes and instantly seeing where they were grown, when they were shipped, and how fresh they are. Companies like Walmart already use blockchain to trade food from farm to shelf, making recalls and safety checks much faster. Or think about healthcare. Instead of carrying test report or repeating scans at every hospital, your medical history could be stored securely on a blockchain. Only doctors you approve could access it, and you'd always know who looked at your records. In education, universities are starting to issue diplomas on blockchain. That means employers can instantly verify your degree, and fake certificates becomes nearly impossible. In finance, blockchain speeds up cross-border payment. Instead of waiting for a bank transfer to clear, blockchain-based payments can settle in minutes with lower fees. Insurance companies are also using smart contracts to automatically pay claims, like when a flight gets delayed or cancelled. Governments are testing blockchain too. From secure voting system to transparent land records, blockchain can reduce fraud and make systems more open and fair. So in simple terms, blockchain is not just about Bitcoin. It's becoming the foundation for safer food, smarter healthcare, stronger education, faster payment, and even fairer government. Every new technology has two sides, the exciting benefits and the hidden challenges. Think of cars. They gave us speed and freedom, but also brought traffic and pollution. Blockchain is no different. It promises trust and transparency, but it also comes with problems we need to solve. Today, let's look at the challenges that comes with it. The first big issue is energy use. In proof of work systems like Bitcoin, miners around the world compete to solve puzzles. That makes the system secure, but it also consumes huge amount of electricity, sometimes as much as the entire country. It raises big questions about sustainability. Second is scalability. Blockchains are secure because every node has to keep a copy of the entire chain. But that means transactions can be slower compared to centralized system. Imagine if every student in the school had to copy every single homework assignment by hand, things would move slowly. Third is privacy. Blockchains are transparent by design. Everyone can see the transactions. That is good for trust, but sometimes you don't want the whole world seeing your activity. Balancing openness with privacy is still a challenge. Fourth, there are regulations and trust. Since blockchain is new, many governments are still figuring out how to regulate it. Different countries have different rules, and that creates confusion for business and users. For kids, imagine a classroom where every student can see the score sheet. It keeps things honest, but sometimes You don't want everyone to know your exact mark. That's the balance blockchain struggles with: transparency versus privacy. And finally, security risk. While the blockchain itself is very hard to hack, the apps and wallets connected to it can be vulnerable. If someone steals your private key, it's like stealing the key to your locker. Once it's gone, your assets are gone too. So in simple terms, blockchain is powerful but not perfect. It faces challenges with energy, speed, privacy, rules and security. The technology is promising, but solving these issues is what will decide how widely it's used in future. Think about the early days of internet. At first, people used it mostly for emails and simple websites. Few could imagine it would one day power video calls, online shopping, social media and even streaming movies on the phone. Blockchain today feels the same. We are just starting to see its potential. Today, let's look forward and explore where blockchain might be heading in future. One major shift is towards greener blockchains. Systems like Bitcoin uses proof of work, which consumes huge amount of energy. But newer methods like proof of stake cut that down dramatically. Future blockchains are likely to be faster, more eco-friendly and easier to scale. Another area is Web3, the idea of a new internet where you own your data. Today, big tech companies control most of what we do online. With blockchain, identity, payment and even social networks could be decentralized, giving more controls back to the users. In finance, central banks around the world are exploring digital currencies, sometimes called CBDCs. Imagine holding digital dollars or digital rupees directly from the government, with instant transfer and no middleman banks. In business, smart contracts will continue to evolve. From real estate to entertainment, more industries will adopt automatic code-based agreements that save time and reduces disputes. For kids, imagine a future classroom where instead of keeping certificates in a drawer, every award and grade is stored safely in a blockchain. Wherever you go, your achievements follow you, secure and verifiable. And beyond that, blockchain may power things we have not even thought of yet. From global supply chain that reacts in real time, to voting systems that are transparent and unhackable, to new kinds of digital communities that run without central leaders. Of course, the future also depends on solving today's challenge: energy use, regulations, and making blockchain easy for everyone, not just techies. But just like the internet, blockchain has the potential to grow from niche idea into something that touches everyday life for billions of people. So in simple terms, the future of blockchain is about going greener, faster and more useful, becoming the invisible backbone of trust for the digital world. Thanks for joining me in this blockchain series on In Simple Terms with Satish. We have gone from the basics of block and chains to the promises and pitfalls of the future. I hope it's made the complicated simple. Stay tuned for our next series where we will dive into another exciting topic in technology. Till then, take care and bye-bye.